Right, let's have a look at this one. It's off a sample paper. So question 2, 2015 sample paper on sets. The universal set is the numbers 2 to 30 inclusive. Okay, so all the numbers from 2 to 30. A is the set of multiples of 2. B is the set of multiples of 3. C is the set of multiples of 5. Okay. So actually, I'm going to write out what A, B, and C are. I think it might be easier to see. So let's write out what A is. So it's multiples of 2, okay? So they start at 2, end at 30. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Very important that when you're writing out any of the numbers in sets, that you write them with squiggly brackets either side, a comma in between each element, and in numerical order. Okay, so B is multiples of 3. So 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And C is multiples of 5. So 5, 10, 15, 20, 25, and 30. Okay, so then we were asked to find hash. Okay, A union B union C complement, the number of elements in the complement of the set A union B union C. Right, a lot of maths or a lot of sets language there. So I'm just going to go to the page in the log tables that does a little bit of sets language. Is here. Okay, so we have intersection, we have union, you have less, null set. Okay, so it can be a little bit useful to help you with some of the language of sets. But what does this mean? Well, the one that's not there is hash. Okay, so hash means the number of elements in. Okay, so it's the number of elements in. Not to name the elements, okay, but how many? So if I was to ask you what is hash C, you would tell me the answer is 1, 2, 3, 4, 5, 6. Okay, so hash C would be 6. Okay, it is the number of elements that are in C, not the actual elements themselves. Okay, so that's hash, the number of elements, okay? And A union B union C is all of the elements in A union B union C, and then complement, I often say not, okay? So it's all of the ones that are not in A union B union C. Okay, so I think the easiest way to do this is to actually draw your Venn diagram. Okay, even though it didn't specifically say. Now it normally does. Maybe it's because it's a sample paper that it didn't, okay? But nonetheless, let's draw our Venn diagram. So we have A, just draw it down a bit more. So I have a universal set, A, B, C. Okay, and then draw the universal set around it. Okay, so that's the universal set. That's A, that's B, that's C. Okay, so A was the multiples of 2, B is the multiples of 3, and C is the multiples of 5. Okay, and if you've been watching any of my USets recordings, you will know that you always fill a set from the inside out, okay? So this area, which I like to call the bud of my Venn diagram or the flower, is where you fill first. So that area is the numbers that are common between A, you can see how the green bit stays in between all of the circles, okay, and C. Okay, it's the one area in the Venn diagram that is shared by A, B, and C. Okay, so when you're drawing a Venn diagram, then you're looking, are there any numbers here that are common in A, B, and C? Okay, so I'm going to start at C because it's the least one. So 5 is not a multiple of 2 or 3. 10, so 10 is there, but 3 doesn't go into 10. 15 is here and here, but of course it's an odd number, so it's not a multiple of 2. 20 is here and here, but of course it's not a multiple of 3. 25 is an odd number, so it's not going to be a multiple of 2. So 30, 30, 30, look at that. We have 1 at the very end. So 30, 30, 30. Okay, so that number 30 goes here in the center. Okay, so that is the only number that is shared by A, B, and C. Okay, and I've already marked into my Venn diagram, so that's why I've crossed it out of A, B, and C. Okay, it is now part of A, see the 30? It is part of B, and it is part of C. Okay, so that's why it gets placed there. Now the next thing you do is you fill from the bud out, okay? So out to these shared areas, okay? So let's perhaps look at this one next. Are there any numbers common? What are the numbers that are common between sets or A and B? Okay, so let's have a look. Let's pick a color. Let's pick green. What is common? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and of course 30 and 30 and 30. Okay, so these are the values that are common between A and B. Okay, but they're not in C. Okay, so none of these 6, 12, 18, or 24 appear in C. Okay, so that's why they don't go anywhere in C. They instead go in this area up here. Okay, so they were 6, 12, 18, 24. Okay, so let's get our red pen and let's cross them off now because they are all now in our Venn diagram. Okay, so what will we do next? Will we do A and C? Okay, so what's common between A and C? Okay, well, let's pick another color. Let's pick orange. So A and C. So 5 doesn't appear there. 10 does. 15 won't. 20 will. Okay, and what I'm doing down here is I'm ruling out any of the odd numbers because an odd number is not a multiple of 2. So 10 and 20. Okay, so that is what's common between A and C. 10 and 20. And let's get our red pen. And they're now also gone. Okay, and lastly, we have what's common between B and C. Okay, so B and C. Let's get a color. Let's get pink. So B and C. I have 15 and 15, not 5, not 25. So just 15 between B and C. Okay, and then the remaining numbers are what's part of A only. So 2, 4, 8, 14, 16, 22, 26, 28. You can see there, it's not part of C. They're not part of B or C, so they're in A only. And this is the area of the graph that is A only. Okay, so if I outline B and C, okay, you can see this belongs to A only. Okay, so what numbers are there? 2, 4, 8, 10 and 12 is gone, 14, 16, 22, 26, 28. Okay, and I often do a check to make sure I have them all. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay, so that is the set A complete. Okay, B then, what's left over for B? So I have 3 and 9, 3 and 9, 21, 27. And in the same way, let's check. So I have 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Okay, so that's set B complete. Then what have I left for C? 5 and 25. And let's check. 5, 10, 15, 20, 25, 30. Okay, and the last job then is to check for the universal set. Is there anything in part of this universal set that I have not accounted for in A, B, and C? So again, you have two ways of doing this. You can write out the universal set, which is all the numbers from 2 to 30, so not 1, 2 to 30. They could have started it at 1. In fact, they can start it at any number they want, but they've chosen to start it at 2. So 2 to 30 is my universal set, okay? So you can write them all out here and cross them off if you wish, or I suppose you can do it here, okay? So what do I mean by that? Well, I'm going to check my numbers. So 2, 3, 4, 5, 6. Okay, 7 doesn't belong to multiples of 2, 3, or 5. So that's 7. 8, 9, 10, 11 is another one that doesn't belong. 12, 13 doesn't belong. I suppose I'm counting up in numbers as I'm doing this. 13, 14, 15, 16, 17 doesn't belong. 18, 19 doesn't belong. 20, 21, 22, 23 doesn't belong. 24, 25, 26, 27, 28, 29 doesn't belong, and 30. Okay, so that's the universal set then filled into the Venn diagram, and that completes your Venn diagram, and there could be a fair old amount of marks for completing that. The question says find the number of elements in A union B union C complement. Okay, so this is A union B union C all inside these three circles. Okay, so how many elements are in the universal set that are not in that? Well, it's these ones on the outside. So 1, 2, 3, 4, 5, 6, and 7. Okay, so I would say hash A union B union C complement is equal to 7. Okay, part 2 of that question says how many divisors does each of the numbers in A union B union C complement have? So divisors or factors, how many factors does each of these numbers have? Okay, so the factors of 7 are 1 by 7. Factors of 11, 1 by 11. There are no other ones. 13, 1 by 13. 17, 1 by 17. I think you're starting to see a pattern at this stage. 1 by 19, 23, 1 by 23, and of course 29, 1 by 29. Okay, so these have two factors, two divisors. Okay, themselves. So the number itself, do you see that? There is 7 and 7, 11 and 11, 17 and 17. So the divisors are itself and the number 1. So each of them have the number 1 and itself. Okay, so the answer is 2, itself and 1. Okay, what name is given to numbers that have this many divisors? Well, these are of course the set of prime numbers. Okay, they have no factors, only themselves and 1. Okay, this is why they weren't multiples of 2, 3, or 5. Okay, so a little bit of revision of number systems here as well as sets.